to this computer. Okay, we are recording. Let's discuss. I hate how glitchy Discord is on Linux. It's glitchy as hell. Let's talk about grep. Grep is a command used for matching a string pattern from one file standard output when you use the pipe, or directly from whatever is inside a file when you use it without the pipe. That means a lot of mumbo jumbo, but putting it in plain simple English, grep is a command that we use for finding a pattern in text. For example, for example, you want to find all the lines in a particular file that contain the word license. The file is 100 lines long. You don't want to open that file to read 100 lines. You run a simple grep command, and you look for, and it's gonna look for those lines that contain the word license, and it's gonna show them to you in the standard output. For example, you have a big file. You want grep to show you all the lines that contain an IP address on that particular file. Boom, grep does that. Let's take a look at some examples of grep. Before that, let's look at some options. You use the -I option with grep when you want to turn off case sensitivity. So you want grep to match the word hello regardless of what case it's using. Uppercase, lowercase, I don't care. As long as it says hello, show it to me. N displays the line number for each line that it match. E treats the particular pattern that you have in there as a regular expression. We are not going to cover regular expressions in this class. You can ignore that. But in the future, you might want to learn about regular expressions. They're very useful. G, capital G specifically, treats the pattern as a regular expression or basic regular expression. V, inverts the search. Look for the opposite of what I'm telling you to look for. O, now, instead of showing me the whole line, I want you to show me only what you found. Let's look at some specific examples. Let me go over the formula real quick. Grep, the option that I'm using, the pattern that I am looking for, and then the file. If I want to use it as the output of one command, for example, I use the cat command, not the cat command, that would be useful to use the cat command with grep because grep can look into files. The IP command, for example, right? When you do IP address, for example. This is a lot of mumbo jumbo, right? But you want to look for IP addresses specifically. For instance, show me all the lines that contain the word inet. You can do this. The IP address, the pipe to send the output of this command as an input to the other command, grep. Then here I'm going to provide the option, and the option that I want is -I. I don't care about case sensitivity. I don't care if it's uppercase or lowercase. And then the pattern that I am looking for is inet. Notice that the only lines that appear in my output now are inet 127, inet 6, inet 192, inet 6, inet 172. All the lines that started with inet.
Professor, what was the used pipes used to be used in database to they used to use it to justify the word in your columns? Is that correct?
Yeah, but the use of pipes in databases is completely relevant to the use of pipes in the bash or in the shell.
Okay.
Here in the shell,
Mhm.
the pipe is used for taking the output of one command and sending it as an input to another command. This is called lending line pipes. And you can do as many pipes as you want. You can literally build an entire humongous argument, an entire humongous command just using pipes. It's one of the things that make Linux amazing. The fact that you can take the output of one command and put it and use it in another one, and in another one, and in another one, and in another one. It's
Mhm.
just amazing. Like DJ Khaled, another one, and another
Yeah.
one. So let's talk about some examples. Search for a given IP string in a file. For instance, give me all the lines that contain the word IP in this file called data.csv. Search for a given string in a file with case sensitivity, -I. Search for a given string in multiple files. You can use multiple files as well. I have two files and I'm looking for something in both files. You look for I want you to find the word user in each and every one of these files and output each line that contains that particular word. For instance, I like this example a lot. Show me, sorry about that, search for a string and show the line number. I want to know how many lines the word license appear in this particular file. This is over here, so let's do exactly that. Grep minus n, the word, and I'm going to also do minus I, right? Because I don't want case sensitivity. And I want to do license and then the file. This user, share, doc, bash, and then readme. Yeah, readme. I don't have a file called readme there. I have one called rbash. Let's do rbash then. And it doesn't appear a single time. So why don't we use readme? Let's take a look at that one there. Readme dot abs guide. Not a single time. Oh, okay. What can I do? I don't have a license file over there in that directory. Give me 1 second, guys. Okay, now let's take a look at more examples. Search and highlight a particular pattern. Provide the minus color option and then option and then the particular string they are looking for. Display all the lines that do not match a particular pattern. Minus V option. Display only the string. Minus O option. And now I want to open my website where I have all my examples that I use on a big basis. And I want you to take a look at these examples over here, right? And actually, I do recommend that you read this article by from DigitalOcean because it is very, very enlightening on the use of grep and regular expressions. So do it on your free time. You're not required to do it for my class. It's just for your enrichment. Okay, let's take a look at this one over here. The caret symbol is used for matching all the lines that start with a particular string. Show me every single line that has the word config at the very beginning. The dollar symbol is used for matching at the end. Give me all the files that end in the word config. All the lines that end in the word config. Sorry, I don't know why I said file. We can also use bracket expansion here. Match all the lines that contain any letter from A to C. Match all the lines that do not contain letters from A to G. See how I use the caret symbol over here for that negation. Match all the lines that start with a capital letter. The caret at the beginning of the brackets, and then A to C inside the brackets. You can also use regular expression character classes here. You can use POSIX classes to represent all of this, similar to how you did with the TR command. Match all the lines that start with an uppercase letter. Caret sign, and then the POSIX class upper. I like this one over here. Match all the lines that contain an IPv4 address. Let's take a look at that. IP, ADDR, pipe, right? Because I want the output of the IP address command send to grep. What if I only want to display the IP addresses? Meaning I don't want no other word other than the IP addresses themselves. Remember the minus O option should displays only the match string instead of showing the entire line. See how powerful is grep? Grep is amazing. What if you want to find all the lines that contain a phone number? Well, this is the format that an American phone number uses. You can use this particular expression over here. And that's going to match phone numbers in American format, obviously. Let me see. Oh, I like this one. I really like this one. Display only the options of any command. For instance, if I do this, to clear man ls, notice that all the options in the man page start with a hyphen, right? Can I write the grep command that is gonna match all the lines that start with a hyphen? Hell yeah. Take a look at this. Man ls, pipe it into grep, and there you go. How cool is that?
That's a useful command.
Very useful. And you want to know how I make it even more useful? I'll show you something. Nano bash bin bash underscore aliases. Here is an alias that I have over here. It's called options. So options right here, right? An alias is just another name for a command. This alias called options is a shorthand for this entire grep expression over here. So whenever I want to see all the options of a command, all I do is this: man ls options, instead of memorizing that particular grep command.
You use the alias you created, right?
Exactly. You want to know how to create aliases? It's very simple. I'll show you. You type the word alias, which is the command used for making aliases. Then you type the keyword that is going to represent that alias. In this case, update. In quote, then you put the equal sign. In quotations, you put the entire command that you're going to replace with that alias. For instance, my update command does first a sudo apt update, then it does an update, then an upgrade, then it does a full upgrade. When I want to search for a program, search apt search. Do I have my git ones here? Yeah. For instance, I use git a lot. Add is equal to git add. Push is equal to git push, and so on. Cool, right? All you have to do is put your aliases inside your bash.alias folder, sorry, direct file, and you will be fine. So in your home directory, you are going to have a file called bash aliases. All you have to do is put your aliases over there, and they will be loaded once your system loads. If you want, I can make a quick lab on how to do aliases. If you are interested in that. In that way, we can do it. I can do it in an empty VM, and we can do it from the ground up so that you can replicate exactly what I have. Aliases are very useful. That's why I put them in all my servers. Okay, let's continue over here. Now that you know how to use grep, let's continue with more interesting commands. The ref command. I call this a gimmick command because all it does is that reverses words. That's all it does. For instance, I can do echo hello, and if I send that to ref, you see, it just reverses the word. I find that a gimmick because I have literally no useful use for that command. If you can come up with one, please enlighten me. I personally don't have a use. I have never used it. Let's put it that way. Let's talk about working with the standard input and the standard output. Important, very, very important. So std in and std out. First, let's talk about what is a file descriptor. As you already know, Linux handles every object as a file. Everything inside a Linux system is a file. Everything, including the input and output of commands. File descriptors are positive integers used to identify open files in a given session, right? We have three file descriptors that are restricted. You cannot use them because the operating system uses them. That's 0, 1, and 2. 0 is for the standard out input. 1 is for the standard output, and 2 is for the standard error. These descriptors are used for redirecting the input and output of commands. By default, the shell redirects the output to your screen. For instance, when you type a command, the output of that command is a file descriptor showing you all of that in your screen. It's by default sent to your monitor because your monitor is by default your output. Standard input. The standard input descriptor references the standard input in the shell. For a terminal interface, the standard input is your keyboard. The standard input for your shell is your keyboard. That's what you're using to input your commands, right? So to replace the standard input as a file descriptor, we use this symbol, which is the less than symbol, right? So for instance, I want the cat command to use this file, users.csv. So instead of me typing, everything that I type over here in my keyboard is gonna be sent to the cat command. Let's do that real quick. Cat users.csv. And by the way, this is a nice way of users.csv, not such a file directory, touch users.csv. Now, let's take a look at the standard output real quick. Now, the standard output is a file descriptor that references the standard output of a shell. On a terminal interface, the standard output is the terminal monitor, what outputs what you see on your computer, right? To redirect the standard output of a command, you can use the bigger than symbol. For example, ls minus l directories. This will save the output of this command to a file called directories.txt. Now, if anyone asks you in an interview, maybe they ask you in a certification exam or whatever, how do you save the output of a command? Simple, by redirecting the standard output to a file using the greater than sign. ls minus l dir. It created a file called dir, and inside dir, save the output of the ls command. Does that make sense?
Yeah, Professor.
Perfect. A standard error. Now, this is used a lot, so it's good for that you know it. The shell handles error messages using the standard error file descriptor. The standard error file descriptor references the standard error output for the shell. This is the location where the shell sends error messages generated by shell or programs, right? As we mentioned before, a standard error is represented by number 2. Now, if you want to redirect a standard error, we use number 2 and the greater than sign, and then whatever file you want to redirect that to. Let me give you an example of what I mean. If I do ls, I don't know, haha. I don't have a directory called haha over here. This is obviously going to generate an error. This is an error, right? I want to save the output of this into a file. Well, earlier I showed you that you use this to save to a file, right? But there is a problem though. Notice that it is still showing in the standard output instead of saving it to a file. That is because this is not file descriptor number 2, right? This doesn't represent file descriptor number 2. For that, I will have to use number 2 and the greater than sign. And now notice that there is no error display on the screen because the error was redirected to the error file. And if I do cat error, that was the error that was saved. I can save the standard output of one command to one file and the standard error into another. And we're gonna see an example of that right now. For example, if I want to redirect the error of a command, I show you already, ls minus l minus l, wrong file 2 is gonna send the error message of this command to the file called errors.txt. Sometimes you want to store the data of errors and the errors that one file is given. For example, you run the command that does something. You want the errors to be saved somewhere, and you want the output of that command to be saved somewhere. You can do this. Number 1, greater than sign, long list.txt, right? The error message will be saved over here in errors, while the output of the proper output of the command will be saved over here. Any question about this command in particular? Let's take a look at the command in actual practice. So we are going to create a file called good file, right? And we're gonna do ls good file. Notice that it shows ls good file, right? It shows me the listing for the file called good file, right? So I wanna do ls good file and bad file. Bad file doesn't exist, therefore it is supposed to show me an error, right? No such a file or directory. I wanna save this error into another file. So I wanna do one. I want you to save the output of the ls minus one good file to good.txt, and then I want the error saved in error.txt. Notice that nothing was displayed on the terminal, nothing was sent to a standard output, everything was saved into files. So if I do cat good and good.txt and error.txt, see, does that make sense? I hope it does.
Yeah, Professor.
Now, in Linux, there is something called the black hole. It is a place where you send something, where you send anything you don't want. That place is called def null. If you want the output of a command to be sent to def null, you don't want to see it in your standard output, all you have to do is redirect it to def null. You can redirect error messages there, or you can redirect the entire output of a command there, whatever you choose. Okay, now,
Professor, does that make it a hidden file when it's in dev null?
no, it's gone. It's gone. It's gone. It doesn't create a file, doesn't do nothing. It's just gone. It's gone with the wind.
Thanks, Professor.
Nothing you send to def null will you will get back.
Becomes black
That's
magic.
why it's called a black hole. It's gone. Okay. Remember I was talking to you about pipes? This is the slide that explains pipes. So the pipe allows you to redirect a standard output of a command as a standard input to another. Here is the formula to use the pipe. Command one, the output of this goes into command two. The output of this goes into command number three. And the more pipes you put, well, the more you're gonna send the commands over and over and over. For instance, use the we can use grep to look for a particular string, right? You know that. So let's use the pipe, grep, and the man command. I am looking for, and this is something you're gonna need for your midterm, because in your midterm you're gonna be timed, and you want to know, you forgot what option does human readable file sizes in the man command, so in the ls command. So if you do man ls and you pipe it into grep,
Dash
and
H.
and you provide human, let's do the string human, right? And I'm gonna do minus I because I don't know if it is written with capital H or lowercase h. It took the output of the man command, it sent it to grep. Grep then went line by line looking for the string human. And every time it finds the string human, it output to the standard output what it found. Does
There's
that make sense?
it does a couple things happening here, but this is very helpful. Yeah.
If human was in caps and you didn't use the dash I, it wouldn't find it.
Yeah, you wouldn't find it exactly. I can show you as in particular. For instance, I'm gonna type human with capital H, and then I'm gonna remove the minus I. Notice that it shows nothing because uh, the word human is typed with lowercase h inside the man page of the ls command. Therefore, it didn't find anything. Minus I turns case sensitivity, and it works.
Usually it's better to search with dash I just if it's a different.
I always search with dash I. Always. Unless I'm specifically looking for something that has case sensitivity, Then obviously I want. Any questions about the pipe?
So, Professor, the pipe will always take what's on the left and take the output basically and make it the input on what's on the right.
Yes.
Okay.
Okay, that's it. That's the end of that particular presentation. And I'm gonna stop the sharing now so that the video, is short. But I have about 15 more minutes to take any questions.
Professor.